Hey there, quick question. When you swallow a basic painkiller, do you ever wonder what it might be doing to your hormones? Most of us don't. We pop the pill, the ache fades, end of story, right? Well, here's the twist. Some chemicals don't crank your hormones up or down in a way your doctor would spot on a blood test. Instead, they quietly jam the off-switch enzymes that tell those hormones, okay, show's over, time to leave the stage. Let's talk about a brand new study from Oulu, Finland, that shines a spotlight on two of those off switches, enzymes called SULT2A1 and SULT1E1. Understanding them could change how we think about everything from puberty timing to fertility treatments. Take a sip of coffee, settle in, and let's unpack this together. Section 1. Hormone traffic, not hormone floods. First, picture your hormones as cars on a busy highway. Traditional toxicology asked, do chemicals dump more cars onto the road? But many modern compounds act more like traffic controllers. They redirect cars or keep them cruising long after the light turns red. Plastics, cosmetics, food packaging, even some prescription drugs fit this profile. They show up in tiny doses, but they're relentless, day after day, often in combinations we never test together. The key point is timing. A quick hormonal traffic jam during fetal growth, puberty, or a menstrual phase can leave lifelong footprints, even if the average hormone level looks perfectly normal. Section 2. Meet the quiet janitors, SULT2A1 and SULT1E1. Here's the thing, SULT2A1 and SULT1E1 are like the janitors who flick the lights off after a concert. Their job is to sulfate hormones such as DHEA or estradiol, tagging them for cleanup so they can't keep signaling. The Oulu team screened hundreds of everyday compounds, prescription meds, over-the-counter painkillers, pesticides, flame retardants, and asked a simple question. Which ones stopped those janitors from working? More than 250 did. Many had never before been linked to sex hormone handling. Let that sink in for a second. Section 3. Diclofenac, a familiar face in the lineup. One blocker jumped out, diclofenac, a super common anti-inflammatory. In lab tests, it inhibited SULT2A1 at concentrations similar to what you'd see in people taking normal doses. That doesn't mean everyone who uses diclofenac will have hormone side effects, but it raises a focused, testable question. Could someone who's already vulnerable, because of age, genetics, or overlapping exposures, experience a real shift in local estrogen-androgen rhythms? Think of a city where garbage collection quietly prevents chaos. SULT2A1 collects excess DHEA, a precursor that can morph into potent sex hormones exactly where they matter most: the brain, ovaries, testes, placenta. Slow the pickup, and garbage piles up in certain neighborhoods, even if the citywide average looks fine on paper. Over months or years, those invisible heaps might nudge puberty earlier, tweak menstrual cycles, or chip away at sperm quality. Section 4. The library analogy. Need another picture? Imagine a library. After you read a book, staff reshelve it. If reshelving slows down, the aisles look normal at a glance, but specific shelves stay cluttered, and readers keep bumping into the same titles. In the same way, when SULT activity is dialed down, select cells keep seeing a slightly louder hormonal book, even while routine lab work appears tidy. Section 5. Real-world playlists. Now zoom out to everyday life. Maybe you rotate painkillers, dab on antifungal cream, sip water from plastic bottles, and take a so-called hormone balance supplement. None of those feels dramatic, right? Yet the Oulu data hint that several could lean on the same molecular door. And if your SULT genes run a bit sluggish, or you're in a transition like puberty, menopause, or fertility treatment, those overlapping nudges may add up. Current safety rules usually look at one chemical at a time. This study pushes us toward a whole-day playlist view, where dozens of mild inhibitors might chorus together. Section 6. Rethinking monitoring. So where does that leave clinicians and regulators? Future risk assessments may need to ask not only, does this chemical turn the signal on, But also, how long does it keep the switch from flipping off? Monitoring could evolve from single lab snapshots to month-long patterns, pairing hormone tests with digital diaries and maybe even genetic profiling to spot who's most sensitive before symptoms ever surface. Section 7. Quick reflection questions. Before we wrap, 3 things for you to chew on. 1. If you listed the 5 products you use most on your skin or in your home, shampoo, plastic containers, candles, cleaning sprays, how many contain likely hormone disruptors like phthalates, BPA, or PFAS? Which one could you swap out today for a safer choice? 2. Where in your daily routine are you getting repeat exposure at tiny doses? Microwaving plastic, handling receipts, using non-stick pans, wearing fragrance? What's one habit you can change this week to cut that down? 3. If a friend asked how chemicals can alter hormone traffic without changing blood levels, could you explain it? If not, what podcast, article, or expert will you check out tonight to fill that gap? Recap. Putting it all together. So here's what we covered today. First, many chemicals don't flood your body with extra hormones. They block the enzymes that switch those hormones off. Second, the Oulu study found over 250 everyday compounds, including the painkiller diclofenac, that jam 2 key off switches, SULT2A1 and SULT1E1. Third, these slowdowns can create silent buildups in sensitive tissues, potentially nudging puberty timing, menstrual cycles, or fertility, even when standard lab tests look normal. Fourth, real life looks like a playlist, not a single track, so overlapping mild exposures may matter most for kids, teens, people trying to conceive, or anyone with genetically sluggish SULT enzymes. Finally, smarter monitoring and small lifestyle tweaks, like swapping a product or rethinking a kitchen habit, can help you lower your personal jam session of hormone blockers. Empowerment close. You now have a new lens for reading labels, talking with your doctor, and yes, challenging old assumptions about normal hormone tests. Until next time, stay curious, stay proactive, and remember, tiny shifts, repeated daily, can add up. So even tiny changes you make can add up too.